Hello, good morning, dear students. So, welcome back to your class. In last class on Wednesday, of course, I have not taken your class, but on Monday we will continue with our class. Okay. So, gravitation is very important part, and whereby we have to learn it in details. Okay. So, last time what we have learned, we have to understood basically gravitation. So we have started with law of gravitation, and it is specially universal law of gravitation. Okay. So I can read your name here. Yes, Neha Chopra is present. Abhay Singh is present. Roll number 121 90119 214. Yes, Karthik is present. Vibha, Harsh, Shrishti. Okay, so I think now you are ready to answer the question. Okay, so it will be quickly recapitulate so that we can continue with the next topics. Ready, students? Yes, just answer me. What is gravitational law and why it is said to be universal? Yes, Priyanshi Giri is present. Correct. Meena is present. Try to answer my question. Akash, Hardik, Garvit. Yes, because all objects in universe attract each other, therefore it is a universal law. Very good, Akash. Yes, Chinmay, Hardik, Saini, Hardik Jain. Yes, Hardik Jain. Gravitational law states that every object attracts each other with a force, and that force F is given as capital G, which is constant of proportionality, product of their masses, capital M, small m, divided by distance between these two masses. Sorry, square of the distance between these two masses. Okay, we have already written that term here. Can you see here? Yes, correct, Hardik. G m1 m2 upon r square. Correct. Body in universe attract each other, and thereby it is called to be universal law. Yes, you are a very intelligent students. You have learned it. You have gone through the chapter. Now we have to learn more basically today. These three topics where we have to focus. Free fall. Then we will try to find the relation between small g and capital G, and we will learn the concept of mass and weight. Yes, you are answering, and I can see it clearly. Parul, yes, you have also answered. Correct. Now, just pay attention, dear student. Yes, you all have answered correctly. Gaurangvi Mehra is also answered. Yes. Now pay attention to the class. Now, we have in the last class gone through the universal law of gravitation, which states that every object in the universe which having mass attracts every other object having mass by the force F, which is directly proportional to the product of their masses and inversely proportional to the square of distance between two masses. This force acts along the line joining the center of two masses. Right? So we have learned this concept. Means Newton provided us with the inverse square law. We have extracted the meaning from it. Right? What is inverse square law? How your force will be increased if D is decreased. If it is D, small d replaced by d by 2, half of the distance means your force increased by 4 times. Yes, and many of our students have responded well in the last class. So now continuing with that concept. how Newton got the idea of inverse square law. So in early century of 16, many astronomers have collected data regarding the planetary motion, and Kepler was the one who studied all that information which was collected by astronomers and put forwarded us three very important laws of planetary motion. Kepler's laws for planetary motions. Okay, so what is that and how Newton led to the inverse square? We have to see it. So initially leftover topic from last class, which is Kepler's laws. So pay attention. Kepler's first law states that I will explain you. Then we will in a short summarize here. Okay. So first law states that the planet or the path of the planet is an ellipse. Okay, the path of the planet is an ellipse with sun at one of the foci. Means this diagram you can see clearly. This point O is nothing but sun, right? And your planet may be at one of the point A or B or C or D. Means when it will revolve around the sun, any planet goes around the sun, it will move in an elliptical orbit. Yes, planet moves in an elliptical orbit with sun at with sun at foci, one of the foci. Okay, so this is important to be understood. Have you got that law? Any orbit, any planet moves around the sun in an orbit of elliptical path with sun at one of the orbit. What does Kepler's second law states? Kepler's second law states for planetary motion that the line joining the planet and the sun means from A to O, the line joining planet and the sun sweeps an equal area in equal interval of time. Suppose I have taken two areas, right? You can see clearly. One area OAB and other area will be from where your planet moving is considered to be OCD. So your Kepler's second law states that the line joining this planet and the sun sweeps an equal area in equal interval of time. And what mathematically we can relate? This triangle OAG will be equivalent to triangle OCD in equal interval of time, right? So it's an equal area in equal time, right? So this is Kepler's planetary motion. This is called as law of area. And third, which is very important, put forward by Kepler. What does it say? What did he say? He said he put us with the law in terms of distance r and the time period t. Distance r means the mean or initially the cube of mean distance of planet from the sun. The cube of mean distance of planet from the sun directly proportional to the square of the time period, that is capital T. Means Kepler's third law explains us. Suppose this distance is considered to be r. So cube of mean distance of planet from the sun is directly proportional to square of the time period capital T, which implies us r cube upon t square is always constant. Okay, so this is our Kepler's third law of planetary motion, which is Very important. We have to learn it. We have to understood it. So how your Newton provided us with the theory behind this planetary motion. How he got that inverse square law. He gone through this Kepler's laws. He given the reason behind this planetary motion. Pay attention. Kepler only understood the statistical analysis put forwarded by astronomers, but Newton was the one who provided us with the theory behind this planetary motion. Yes, Newton explained us that this planetary motion is because of gravitational force which is provided by sun on the planet. Because as considered sun having a bigger mass than the planets. So gravitation force offered by sun on the planet giving rise to this planetary motions, and these three laws are put forward there. And through this study, gravitational law was explained in terms of inverse square law. Okay, so I hope you have understood these three laws, which is very important. And now we will pay attention to this free fall. Okay, now logically we will go to this term only. What we knew already, what we have learned already, we knew that if you will throw this object, for an example, suppose I will throw this chalk, right? So what happens? It will reach to the certain height, and from that height, it will start falling down. Okay. If you are throwing any object, like if you are sitting there and having your pen, you can just try it. If you will throw your pen, it will suddenly come back to your side only, right? It will reach to certain height and then starts falling down. So why it is so? Why your object reach to certain height but starts falling down? Because of the force of attraction offered by the earth. The force of attraction is offered by earth on the object, so object will fall down. And yes, and why this attraction is there? Because of gravitational force. Because of gravitational force, earth can attract object towards it, and thereby object starts falling towards the earth. And this phenomenon, when an object starts falling downward due to gravitational force alone, we are neglecting other terms, okay, like air friction or air resistance. So only the concept gravitational force alone. When any object falls due to the gravitational force alone is called as free fall. What is free fall? When any object falling towards the earth under the action or under the influence of gravitational force alone called as free fall. Then does the velocity, what will be the idea regarding velocity in this term? Do or does the velocity changes in this free fall? Yes, if you are throwing any object at reaching certain height, it will start falling down. So we are considering only the term fall. Yes. So free fall. So during this fall, direction is constant. Yes, the direction of this velocity. Direction for this velocity will not change. Then what is changing? Because of gravitational force of attraction, the magnitude of this velocity changes, right? Magnitude will be changing with linear change with respect to time. Yes. What happens in free fall when any object coming towards the earth because of gravitational force alone, then called to be free fall. What happens during this free fall? The direction of the velocity will not change. But because of gravitational force of attraction, the magnitude of velocity will change, and any change in the velocity involve acceleration. Right? Any change in the velocity involve acceleration. It says that when any object falls under the gravitational force, under the action of gravitational force, the acceleration is involved. And this acceleration due to gravitational force, the acceleration due to gravitational force is called as acceleration due to gravity. Yes, this acceleration is called as acceleration due to gravity, and this is denoted by small g. It is called acceleration due to gravity. What does it mean? Acceleration due to gravitational force. It is small g. Yes, today we have introduced with a new term, that is small g. And in previous class we have already understood the concept of capital G. Yes, so you can clearly see here the next point which is to be learned, that is relation between small g and capital G. Okay. So dear students, just pay attention. Now we will try to find the relation between small g and capital G. Here we have introduced with the idea of capital G. It states it's a universal law, right? So if we have to find the relation between small g and capital G, we will first start with considering two objects. And suppose let one of the object is Earth. Okay, जो भी object हमें लेना है उसमें से one will be Earth. So one of the object will be Earth. Please, one of the mass will be mass of Earth, which is denoted by me. Okay, and other object will have mass small m. Now the distance between this m and small m. If suppose I have considered this is as a Earth, it is the center of the Earth. Okay, it is, I'm not drawing it. You can draw it. So this is your mass of the Earth at the center, and any object is at this place small m. So distance small d for this two object can be considered as a radius of the Earth. Obviously, center of the Earth and any object will be considered to be at the surface. Means the distance will be taken as radius. Means radius of the Earth. Small e. Earth. Small e for Earth. Right? R for radius. Small e for Earth. So it will be considered to be your RE. Are you getting my point? We understood the concept of free fall, and from there we are trying to relate this small g and capital G. For that, we have considered two objects. One of them is Earth, and any other object like a chalk which I have thrown, or any pen which you are carrying now. Right? So that pen or you, any one will be the other object, small m, and mass of the Earth is capital M. And distance between these two will be small d replaced by radius of the Earth r. Okay, so now your universal by first law in last class which we have already learned, or I have written here also. So by universal law of gravitation, what we will have? By universal law of gravitation, we can write the force acting on these two objects will be F equivalent to gravitational constant G, mass of the Earth M, mass of the other object upon distance between these two objects means radius of the Earth whole square, RE square, right? This is considered to be our equation number 1. Done. This is by universal law of gravitation. Okay. So this was the term which we have learned in gravitation only, but it's on previous topic we have understood this universal law of gravitation, and today also we have revised it. Have you understood this? How we will lead to this concept of equation 1? It is very easy. Only we have introduced the concept of universal law of gravitation. Okay, now next, what we will get here? Now next, we will introduce the term for small mass L. We already in previous chapter where we have studied force and laws of motion. Yes, there we have learned one concept of Newton's laws of motion and especially Newton's second law of motion. What does it say? The rate of change of momentum directly proportional to the, yes, explain what is your Newton's second law? Can you tell me what is Neelam? Neelam, please explain what is second law? Praveen Kaur, Hardik, what is Newton's second law? The rate of change of momentum is, are you listening to my class? No, actually it's time at 12. No? So eating your food and having a nap, right? No? Yes, Hardik. The rate of change of momentum is proportional to force. Correct. So now this is a, yes, correct, Akash. Proportional to the force. Very good. In the direction of force. Correct. So are you getting the point? What we are trying to find here? It is Newton's law of motion. And which object is found to be in motion? Which has small mass according to the gravitational force. Because as apple is attracted by the bird, earth is also attracted by the apple. But the motion will be in apple only, which has a small mass. It will have a higher acceleration. Yes, correct. Right? So thereby, now using Newton's second law of motion, what do we will have? The force is given by mass into acceleration. Yes, small a. But now we have already learned the concept of free fall, right? And we have introduced with the small g. So this acceleration is a here. Yes, probably ma, mass into acceleration. But now the question is, a will be replaced by g. Yes? Yes, correct. Means our force is equivalent to mg. We have already learned the concept of free fall and we understood any object falling downward is accelerated due to gravitational force called the free fall and provided with the acceleration due to gravity as small g. So one side we have already learned force is universal gravitational law. There we have introduced the concept of capital G, M, E, M upon R E square. And now second, it is on small m. But my point of view, have you cleared it? I just want to explain you why Newton's second law is acting on small m only, because the only thing is accelerating. If it is in motion, then only we can apply Newton's second law for small m, right? Now, this weight of, actually I am not cleared in the term of weight and mass, and of course we have to continue with this topic only, right? After this we have to see what is weight, what is mass. Still you just go through this definition clearly. So I will explain you next to that also, right? From this weight, concept of weight. Weight is, or weight of any object is equivalent to gravitational force. Weight of an object is equivalent to gravitational force, means Fg. So from equation 1 and 2, what we can see? We can see that one side F and F are equal. So next side should be equal, right? So from 1 and 2, what we will write? We are able to write mg is equivalent to capital G me small m upon RE square. Right? And from there, your small m will be cancelled out, and the equation for G is equivalent to capital G ME upon RE square. So, this is the mathematical relation for capital small g in terms of capital G, which we have to already clear that we have to understand the relation between small g and capital G, right? So, small g is acceleration due to gravity, and thereby SI unit will be meter per second square, right? It is very simple. We know that we have replaced A means acceleration. So its unit will be meter per second square. Right? So here we have completed with this second point of today's class. So we can use this equation of small g to calculate the value of g on Earth's surface. Okay, on Earth's surface, we try to find the value of gravitational force, or sorry, the acceleration due to gravity. How we can calculate that? We will try to find it out on the Earth's surface. What will be the value of small g? Okay, so it is very easy. Value of small g on Earth's surface. Okay, so what do we get? We know small g for Earth. We have to calculate it. So capital G, it introduced with mass of Earth, and it will introduce with RE square. Now we will put the values of this. Capital G is equivalent to 6.7 10 to the power minus 11 Newton meter square per kg square. Then mass of the Earth, it is provided in your NCERT textbook, right? Yes, it is equivalent to 6 into 10 to the power 24, and it is mass, therefore kg. And radius for the Earth is 6.4 10 to the power 6 meter. I have provided you with all the necessary data. What we have to do? We have to put the value in this mathematical relation being 6.7 10 to the power minus 11 into ME means 6 into 10 to the power 24 divided by 6.4 10 to the power 6 square. Do not forget the square. Even in numericals you do this, and thereby we can do our silly mistake and got wrong answer. So pay attention to the square. Okay. Even from there you can find your unit. What will be the unit? If you are keeping the unit like this, Newton meter square upon kg square, right? And this kg, which will be introduced with the term mass, right? And divided by meter square. So it will be introduced with the meter per second. The unit for this term will be introduced as meter per second square. Okay. Now, what will be the value for this? We will get the g, small g. You need not to write e, but I am just explaining because we can even find the acceleration due to gravity for moon. Okay. So small g is equivalent to the term of 9.8 meter per second square. Okay. Small g will have the value of 9.8 meter per second square. Okay. See, if you try to find its unit as I have explained to you earlier, you have to even explain the Newton there. if you will write the unit of Newton in its actual terms, that is force is equivalent to mass into acceleration, means it will be again converted into kg, right? Into meter per second square, then kg will be cancelled out. Have you understood how we can reach to this SI unit? Either you have to learn it directly or you can substitute the value here. Okay, so what we have done, we have understood the relation and calculated the value for G. Can you find SI unit? It will be GE. What will be the SI unit for this? It will be Newton. Newton is what? Mass, right? Into kg, right? So kg will be here. So it will be in terms of kg meter per second square, right? And then meter square already will be there. Then divided by kg square, right? Again, mass will be there, kg in product, and divided by your meter square. So this meter square will be cancelled out, kg will be cancelled out, and G will have SI unit as meter per second square. Okay. So this is nothing but the replacement of Newton. Done. So we have calculated the unit and the value for this. Yes, value for this small g on Earth surface. Now we have to pay attention to the shape of the Earth. Okay, so that we can actually understood the value of g. You know that Earth is in a spherical shape, right? In science, we understood that any planet having spherical shape. Okay. Now this sphere for Earth is not a perfect sphere. Yes, it is actually. The shape of the planet is not a perfect sphere. Rather than this, it is actually somehow in a elliptical shape or oval shape. Oval shape like this. Okay. It is flattened at the equator. Okay. This is pole considered to be your pole, and it is dividing the Earth. This equator. Okay. So what will be the relation for this pole and Earth? This is Earth. What I am saying you, what I am explaining you, the shape of the sphere, the shape of the Earth is not the exact sphere. It is somehow oval shape or elliptical shape, right? So here you can see the radius of the Earth at pole is start increasing towards the equator, right? This is the radius of the Earth at pole, which is RP, and this is the radius of the Earth at equator. So, as it is flattened at its equator, means its radius will be greater at the equator as compared to radius at the pole. Means radius R starts increasing towards the equator, and from here you can consider the concept of radius of the Earth at equator is greater than radius of the Earth at pole. Okay. So what it will explain you? Yes, it will lead us the idea of small g is inversely proportional to radius R. See, capital G is universal constant 6.67 10 to the power minus 1 Newton meter square per kg square, and Le is a mass of the Earth. It will remain constant, right? So thereby your G is inversely proportional to R, means radius of the Earth, and it will be vary according to the pole and equator. Means what we can say? We can say that the gravitation at pole will be greater than gravitation at equator. Okay, this is a very important concept to be introduced. Yes, we have to learn this term that radius at pole, obviously of the earth, radius of the earth at pole is less as compared to radius of the earth at equator, and as per the formula G is inversely proportional to R E square, we can say that the gravitation due to acceleration due to gravity at pole will be greater than acceleration due to gravity at equator. Okay, so because of its not perfect spherical shape, radius changes, and thereby the G will vary at pole, and thereby G will vary at equator. But on the surface, we consider to be it constant. Only near the surface, the value of small g considered to be constant. Okay. So we have to understand how it will lead to the idea of this. Yes, this is also true for the linear equation that any object, just pay attention, but now we have to relate it to the kinematical equations. In chapter 8, where we have studied motion, right? We have learned three very important laws of kinematical motions. V is equal to u plus at, s is equal to ut plus half at square, and s is equal to ut. Sorry, v square is equal to u square plus 2as. 2as, acceleration due to gravity, now to be introduced there. Why? Because g is, this value of g is near constant, considered to be constant near the surface. Okay, so what it will lead us if it is considered to be? So what will be the benefit of this? It was the experiment which was held. They have tried to left any object, okay, from certain height, and they will reach to the earth at the same time. Again, by the relation, small g is what? Pay attention to this equation. Your small g, from that equation, small g is independent of small m. So, if you will throw either small object or big object, okay, if you will throw hollow object or solid object, they will reach to earth surface at same time. Okay, it is very important conclusion from there. G is constant near the surface, and your G is independent of mass of the object. Therefore, the small or big, hollow or solid, each object will reach to the Earth's surface at the same time. And this concept lead us to the kinematical equations in terms of G. The kinematical equations in terms of small g will be V is equivalent to U plus small gt. Okay, this will be the small g. This is your first equation. Then S is equivalent to ut plus half g into t square. This is our equation 2. And third, b square is equivalent to u square plus 2 times of g s. This is our equation number 3. Called to be kinematical equation of motion. Okay? Are these equations correct? V is equal to u plus gt S is equal to ut plus half gt square, and v square is equivalent to u square plus 2 times of as. Right? So here we have understood your equations like kinematical equations. Okay. From here, u is, what will be u? In this equation, u will be, yes, answer me fast. We are about to reach 40 minutes, so just answer me quickly. Yes, Saranya Kumar, correct. Yes, in free fall, correct. Yes, Neelam Sisodia, very good. U is initial velocity. Initial velocity. V will be final velocity. Okay. And G will be acceleration due to gravity. What will be the value of S? What will be the meaning of S? S is the distance or displacement of the object. Correct? So here we have covered very important topics today. We understood free fall. Any object fall under acceleration due to gravity alone called to be free fall, and this creates acceleration in the object with small g called as acceleration due to gravity. On Earth, it is 9.8 with the unit meter per second square. You can calculate yourself for more. Okay, in the next class, I will ask you the answer for more. The gravity g on moon. Okay, and you will try to difference between mass and weight. So today we again left with one topic, the difference between or the meaning of mass and weight. So in next class we will do that. Okay. So for today, dear students, it's all from my side. Thank you. And in next class we will deal with various questions. Okay.